So the first part is asking you to find the mean, the median, and the mode. So to calculate the mean, we add up all the numbers and divide by the total number of items. 41 divided by 1, 2, 3, 4, 5, and we get 8.2. The median, please remember that in order to get the median, what do I have to do first? Organize them from least to greatest. So 5, 6, 8, 10, and 12. And the median is the one right smack in the middle. So 1, 2, 8 is the median. In this case, there is no mode because none of the numbers repeat themselves. But remember that the mode is the number that repeats itself the most. So again, the mean is the average. You add them all up and divide by the total number of items. So when we added 2 plus 5 plus 7, 9, 10, and 36, plus, don't forget the other ones down at the bottom, 37, 41, and 42. We added them up and we got a total of 189, and we divide by 1, 2, 3, 4, 5, 6, 7, 8, 9. And when you divide 189 by 9, you get exactly 21. That's the mean. The median, remember we have to organize it from least to greatest. So if I organize the data from least to greatest, the first number will be 2. It looks like they are already organized from least to greatest. 5, 7, 9, 10, 36, 37, 41, and 42. And the median, which is the one in the middle, 1 and 2, 3, and 4. The median is 10. What would have happened if I had 2 numbers in the middle? What would I have had to do?
Add them up and divide by 2.
Exactly. Add them up and divide by 2. So for example, changing this question, if 42 is not part of it, then when I went out working in 1, 2, 3, I would have 2 numbers in the middle, and then in order to calculate that, I would add 9 plus 10 divided by 2, and I would have gotten 9.5. But in this case, the median is the perfect 10. Is there a mode for this?
No.
There is no mode. Again, remember that mode means most often repeated. So if I had an additional 37 thrown in, then 37 would have been the mode. A stem and leaf plot is a way of abbreviating numbers so that the stem represents, in this case, 40-something. So 45, 48, 51, 55, 57, and so on. And with a stem and leaf plot, you organized your data so that you could actually answer all of these questions with that stem and leaf plot because it's already organized from least to greatest. The smallest number from this list is 45 and the highest is 100. This represents data that was collected in Mr. Lissy's social studies class, and these are all the test scores. So if they wanted me to find the median, they want me to find the middle number. So you can just as easily find the middle number by remembering that when you're finding the middle number, you're working from the outside, the 2 outside numbers in. So not 45 or 100, that's 1, and I'm working my outward in. 2, noticing that the next greatest would be 99. Then 3, 4, 5, 6, 7, 8, 9, 10, 11, and it's going to be the middle of 78 and 79, which would be 78.5. it took a lot of practice for me to be able to work from the outside in with this specific table. So if you have a hard time working from the out in using the table, you could just write all of the scores, 45, 48, 51, 55, 57, 57, 62, and so on, and then work from the outside in. The mode, which is the most often repeating one?
81.
Yeah, 81. There's 1, 2, 3, 4 81s. So the mode is 81. What is the range of the data? Well, what does range mean again?
Highest number minus
That's right.
lowest number.
It's the highest minus the lowest. The highest number is 100. The lowest number is
45.
45. And 100 minus 45 is
45.
55. So the range is 55. Number 5, there are 22, 21, 24, 23, 26, 23, 28, 24, and 25 students in the homerooms at Morgan Middle School. Find the measures of variation. All right, so when you're finding these measures of variation and you see range and interquartile range and outliers, remember that the range is the largest minus the smallest. So the range would be the simplest to find because the highest number is 28 and the lowest is 21. So the range is 7. Interquartile range is a little more complicated because I have to remember that interquartile range is the upper quartile minus the lower quartile, and the upper quartile is considered the median of the upper half, and the lower quartile is the median of the lower half. So before I can even get the interquartile range, I have to find the upper quartile and the lower quartile, and to do that, I have to arrange everything from least to greatest. So I list my data, 21, 22, there are 2 23s, and 2 24s. There's a 25, a 26, and a 28. And now I'm just going to count to make sure I didn't miss anything. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember that in order to find the upper quartile, you first have to find the upper half. Same thing with the lower quartile. So first we have to find the median. And to find the median of all the data, you work outwards in. 1, 2, 3, 4. The median is 24. Then I look for the upper median. 1. Oh, it's going to be in between these two. So that means that the median is, what's between 25 and 26?
25.5.
25.5. This is called the upper quartile.
Wait, you said?
Then for the lower quartile, not 21 or 23, so that's 1 and 2. So it's going to be between 22 and 23, which is 22.5, and this is the lower quartile. So in order to get the interquartile range, I am going to do the upper quartile of 25.5 minus the lower quartile of 22.5, and I am going to get 3. The interquartile range is 3. If I was to create a stem and leaf box and whisker plot with this data, the outliers, if we look at the lowest is 21. 21 is only 3 units from the median, which is 24. 28 is only 4 units from the median. Therefore, there are no outliers because they're all pretty close together. If there was a number like 40, that it's much greater distance from the median than the lower part is, then that would be the outlier. But in this case, there are no outliers. So outliers is none. Let's make a box and whisker plot out of this data. If I was to create a box and whisker plot from this data, I would make my number line. I would probably count by ones because 21 and 28 are pretty close together. So we have 21, 22, 23, 24, 25, 26, 27, 28. The median would be not 21 or 28. That's 2 and 3 and 4. The median is 24. So that means that I start with that there. 21 is the lowest point, 28 is the highest point. To find the median of the upper half, I start outwards looking in. The median of the upper half, which we call the upper quartile, is 25.5.
You have 8 numbers on the bottom and 9 on the top one.
Then the lower half would go now between these two, so the lower quartile is 22.5. Now we make a box out of the medians, extend out my whiskers, and that's your box and whisker plot. Number 6, they want me to figure out the interquartile range. Again, interquartile range may probably be the most difficult one that you have to do because you have to figure out the upper quartile, which is the middle of the upper half, and then the lower quartile, which is the middle of the lower half. So in order to do that, you have to organize it from least to greatest. The lowest is 21, then comes 39, then we have 42, there's 2 45s, 48, 51, 55, 57, and 62. Just count to make sure that you've got in all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember that in order to get the interquartile range, you have to find the middle of the upper half, the middle of the lower half. But before you do that, you have to have the middle of all of the data. The middle of all the data would be going outward in. So 1, 2, 3, 4. It's going to be between 45 and 48, which remember that in order to do that, you have to do 45 plus 48 divided by 2. And when we average those, or we find the mean of 45 and 48, we get 46.5. So the median is 46.5. That's the middle part right there. Now we're going to find the middle of the lower half. 1, 2, it's perfectly 42. So the lower quartile is 42. The upper quartile, 1, 2, is perfectly 55. So the upper quartile is 55. And the interquartile range is the difference between 55 minus 42, which gives you 13. That's the interquartile range. Okay, number 7, box and whisker plot. This one is probably going to take the longest time. You are going to have to make a box and whisker plot. So let's get this data all together. First of all, in order to, and I've been making box and whisker plots for the other numbers, the previous questions, even though you didn't have to make sure that you could do this. So if I was to do this, the very first thing I could have to do is organize it from least to greatest. The smallest number is 1.0, then comes 1.2, then comes 1.3, then we have 2.1, 2.2, 2.6, 3.2, 3.6, 4.2, 4.3, 4.5, and 4.6. Count to make sure we have them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We organize it from least to greatest. In order to make the box and whisker plot, I need a number line. And with this one, because there are tenths, I would probably count by halves. So I would start with 1.0, 1.5, 2.0, 2.5, 3.0, 3.5,
These are bigger numbers.
4.0, 4.5, and 5.0. The reason that I would count by halves is because we have tenths that we're talking about. And if you think about like the 4 point somethings, we have 4.2, 3, 5, and 6. So we're going to have to be able to move within this quite a bit. Once we do that and we get our number line all situated, you can begin by starting with the lowest quantity, which is 1.0. Put a dot above him. And the highest quantity, which is 4.6. 4.5 is right here, so 4.6 is just a little bit above. Those are your two maximum and minimums. Then in order to find the middle, you're finding the median of all of the data. So start from the outwards and work in. 1, 2, 3, 4, and 5. So the middle is going to be between 2.6 and 3.2. Remember that when you're finding the middle of two numbers, you add them up and divide by 2. When you add 2.6 plus 3.2, you get 5.8, and divide by 2 and you get 2.9. That means that the median is 2.9. So we're going to go to the number that's really close to 3.0, which is right here. Just above it, draw a line through it because that is my median. Then I find the lower quartile, which is the middle of the lower half. Now, I like to make what I call the wall that separates it. 2.9 is the median that separates everything. Then you go from the outward in. So we're going to start looking for the middle of the lower. So 1, 2, and it's going to be between 1.3 and 2.1. So I'm going to say 1.3 plus 2.1 divided by 2. And remember, the reason we're doing this is because we have two numbers, and the middle of them is 1.7. So the lower quartile is 1.7. If this is 1.5, 1.7 is just a little bit above. That's the lower quartile. The upper quartile, remember my wall is right here, so you count 3.2. 1, 2, between 4.2 and 4.3 is 4.25. But if you couldn't do that in your head, you add the 2 and divide by 2. 4.2 plus 4.3 is 8.5. Divided by 2 is 4.25. 4.25 is halfway between 4.0 and 4.5. This is the upper quartile. Now, you make the box out of the medians, which is like this, and extend out the whiskers. That is your box and whisker plot. Then we have number 8. Fine. So when we look at this, unfortunately, because I got this off of an image, it curved. But in reality, it should be straight like this, and it should be 140, and here's the 150 should be like right here. So anywhere between 140 and 150 is a true statement. There's no way for you to be exact. This is just an estimate. So if you said 145 and I said 148, it's still okay. It's between 140 and 150. So the highest time is about, let's say 145, about that. I'm just going to write that. What is the median? Yes, the median is the middle number, this one right here. And range is largest minus the smallest. So this would be like, this looks like what, 73? Yeah. So the range would be like 145 minus 73, which, or something close to it. Again, you could have said something a little bit different as long as it was in the same area. What if I asked you what is the interquartile range?
Whatever the highest number is. Or no.
The lower quarter.
Like one.
Very good. Yes, it would be the upper quartile, which is about 112, and again, you could have said 111 or 113, minus the lower quartile, which is 95. So 112 minus 95, and we do the math, and we would have gotten about 17. So it asks me to make a histogram. On the test, I am going to give you this here, where you can make your X and your Y coordinate. In this case, if I look at my table, it's telling me the number of pets. So maybe the title of this will be number of pets in a home. That's the title. You could put it down at the bottom or at the top. The frequency tells me how many of the groups there were. So people had between 0 and 1 pet. 4 families had between 0 and 1. So my intervals are going to go down at the bottom. 0 to 1, 2 to 3, 4 to 5, 6 to 7. The frequency is what goes on the y-axis. And if I look at these, I have between 1 and 10.
Oh.
So we're going to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 was the highest. When I look to see how to make the bars, I am going to make the bars all together with no spaces between them. 0 to 1 pets, there were 4 total. So I am going to go up to 4, which is right here. And I am going to make a bar. That is my 0 to 1. Between 2 to 3 pets, there was a total of 10. So I'm going to go up to 10, and I'm going to make a bar. Notice that there's no space between them. 4 to 5 pets, there was a total of 3 people that had 4 to 5 pets. So I'm going to go up to the 3, which is right here. And I'm going to extend that out to make a bar. And between 6 to 7, there was only 1, so I'm going to go to 1 and make a bar. So in reality, you've got bars that are all grouped together. There's no space between them. And the bars represent how many families there were that had this many pets for this example. Similarly, you have to be able to interpret a histogram. You have to be able to answer questions based on this. Looking at this, we're looking at it and we could see that the cost to go to different sport activities at a high school, there are 4 events that cost between $0 and $4.99. There's 8 events that they have that cost between $5 and $9.99. There's 6 between $10 and $14.99. There's 4 between $15 and $19.99, and then there's 2 between $20 and $24.99. The question says how many events cost more, $10 or more. So $10 or more represents this and higher. So that is, there's 6 here, plus 4 is 10, plus 2, there's a total of 12 events. when we look at this spinner, and we're making believe that we have a spinner that spins randomly, or that we spin it, and we have a little arrow. So the probability of spinning an even number, well, there's 3 even numbers out of 6 total. That is 1/2. How do I write that as a decimal?
50%.
As a decimal, 1 divided by 2 is 0.5, and as a percent, 50%.
What do you want us to write it as?
You will need to write it as all 3 ways.
Oh.
As a fraction, then to change it to a decimal, you just do 1 divided by 2, and you have a calculator,
We
so,
really need all three.
and then 0.5, and then changing that to a percent, you move it 2 to the right, and you get 50%. Now, for letter B, it's just asking for the percent. So, what is the percent of spinning an odd number? 50%. What is the probability of not spinning green and red?
4.
So that means not green and red. So there's 1, 2, 3, 4 out of 6, which remember to always simplify. If you do not have it simplified, you're going to get a little bit of points taken off. 4/6 simplifies to 2/3. And 2 divided by 3, because remember, a fraction is a division, top divided by bottom. 2 divided by 3 is 6.6 repeating, which is 66.7 if we rounded percent. What is the probability of picking a red marble? Well, when we look at the bar, our bag here, you've got red here, the word red here. So that means that there are 2 reds, and then we have to figure out how many there are altogether. There's 2 reds out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 out of 12 is 1/6. 1 divided by 6 is 0.16 repeating, which rounds to 0.17, which is approximately 17%. What is the probability, what is the percent of picking a green marble? Well, we know it's out of 12, and there's only 1 green right there. So 1 out of 12. Remember that as a percent is what they're asking me. So 1/12 is 1 divided by 12, which is 0.083, but that's not my answer because they want percent, so I move it 2 to the right. 8.3%. What is the probability of not picking blue? Well, 1, 2, 3, 4, 5 blues out of 12. So 7 out of 12 is not blue. And 7 divided by 12 is 0.583 repeating, which as a percent is about 58.3%. This is everything that's on the test. This is the last test of the year before your exam. Please remember that you can have notes, but they have to be your own notes.